We will start a new series, sum series to integral. Okay, so we were doing a series called vector summation and integral calculus, dividing problem into n different parts, dividing problem into n different parts, and then solve part by part. Okay, in that series only we will proceed and we will focus on the sum series to integral. Sum series to integral means there are many series we are seeing like 1 plus 2 plus 3 plus 4, 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6, 1 by 1 whole square plus 1 by 2 whole square plus 1 by 3 whole square plus 1 by 4 whole square, 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Okay, 1 square plus 1.5 whole square plus 2 square plus 2.5 whole square plus 3 square plus. There are innumerous summation series. Whatever categories we believe that they can fall in different categories, summation by summation, we will solve it. Okay, but concept is we are bringing a new discussion, that is dividing problem into n different parts and then solve part by summing it and then using integral calculus. Okay, this at least I have not seen anyone using. This is a completely new technology, that can we find the summation of a series through integral calculus. Make sense? Okay. Now we will start with the example. Okay, so some series we are talking some series, then how we can solve something like that. We will start with the simplest example. Consider simplest example is 1 plus 2 plus 3 plus 4 plus 5 plus 6 or something like that. Okay, this is a function over x called up. We'll start again. 1 plus 2 plus 3 plus 4 plus 5 plus 6. It goes upon and to up to any x. What is the summation? 1 plus 2 plus 3 plus 4 plus 5 up to any summation x. What is the summation? Okay, let's divide into if I or 1 plus 2 plus 3 plus 4 up to n. So this is a big summation we have to do. 1 plus 2 plus 3 plus 4 plus 5 up to n. Okay, if people are watching it minutely, then 1 plus 2 plus 3 plus 4 plus 5, I can consider all as an outcome or all as an event. 1 is an event, 2 as an event, 3 as an event, 4 as an event, 5 as an event. There are different events. Okay, if there are different events, all events are mutually exclusive to each other. They follow IID, independent identical distribution. I mean 1 plus 2 plus 3 plus 4 all have nothing to do with itself. If I say what is 2 plus 3 provided previous one is 1. What is 2 plus 3 provided the previous term is 1? Doesn't make any sense. Either it is 1 or 0. 2 plus 3 will always be 5. Means no one is related to anyone. All are independent and identical to each other. 1 plus 2 plus 3 plus 4 plus 5. I can divide into n different parts. 1 is 1, 1 is 2, 1 is 3, 1 is 4, 1 is 5, up to n different parts. Now I can address it as x plus x plus x plus x plus x up to n times. N times. X is 1, 2, 3, 4, 5. X is variable. So in a notebook, I am writing it down now. X plus x plus x plus x plus x up to n time. Okay, where x is varying. So what I am saying is, consider this is x-axis. This is x-axis. At x equal to 1, I have a function fx equal to x. Fx equal to x, which is sample fx equal to x. Fx equal to x is a slant line. Fx equal to x is a slant line. If slant line means whatever the x is, if I take vertical, it will go and hit this slant line, and this vertical height will be exactly as the horizontal. Same. Note it. that is function over x equal to x. Now I have to do sampling of this at x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to n. And if I do sampling at x equal to 1, I have height as 1. X equal to 2, I have height as 2. X equal to 3, I have height as 3, like that. At x equal to n, I have height of n. What is the addition? But now if I use the kind of a summation, then there is a sigma sign. X equal to 1 to n fx, where fx is x, means 1 plus 2 plus 3 plus up to n. Make sense? Okay, now there are two ways. What is the first step? First step is whatever is available, divide into n different parts. And make sure that all parts are exactly same. How it is same? One is 1, one is 2, one is 3. Let's say it is x. Then all are same. All are same. All are x, 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 where x is variable. Second thing. Now, if I say I have x plus x plus x, consider it is x times x or x, I can say fx. Fx plus fx plus fx plus fx plus fx. How many times? X times. That can be written as fx into x. It is similar to if I say 5 plus 5 plus 5 plus 5 plus 5, how many times? 7 times. 5 into 7 can be rewritten as 5 into x, where x is 7. Can be rewritten as 5 into dx, where dx goes from x equal to 0 to 7. Okay. Similarly, if I have fx, 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 how many times? X times. Fx function over x into x, function over x into dx, where x will go 0 to n, where x will go 0 to n. Then what it will come? X dx, x square by 2, 0 to n, n square by 2. This is called repeated addition. We created a scenario where we have repeated addition of function over x, that is x. Repeated addition of function over x, function over x, function over x, function over x into x time, and that will result in fx dx and integration 0 to x. It will give a rough idea that what can be the net summation, and that net summation would be x square by 2. The net summation would be x n square by 2. Okay, n square by 2. But this may not be a perfect solution. Summation of 1, 2, 3, 4, 5, 6 up to n is not n square by 2. It is similar to it, but this is not the exact solution. What can be exact solution? Okay, focus here. What can be exact solution? What is fx? Because this is fx. This is slant line is fx. What is fx? This is fx. Function over x is x. And what we are trying to do now? We have sampled this function over x n times, where x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to n. N time we are sampling this fx equal to x n times. N times. First time if I sample, then height is 1. Second time at x equal to 2, if I sample, height is 2. Third time x equal to 3, if I sample, height is 3. 4, 5, 6, 7, 8, 9, 10, like that. At n if I sample. So at the end, I have a function called fx, but it is not a continuous function. It is rather than a discrete function. Discrete function means it is sampled at many locations. Sampled at x equal to 1, okay. Sampled at x equal to 2, then it is sampled at x equal to 3. It is a discrete function where I am trying to add all the heights. That's it. I do not worry I do not worry what is the gap between these two, but gap is 1. Between these two, gap is 1 whatsoever. I want 1 plus 2 plus 3. That is summation of x equal to 1 to n fx, where fx is x, means 1 plus 2 plus 3 or something like that. Now consider I have to use integral calculus. One integral calculus I have done, that is repeated summation. We will go with another integral equation, another integral calculus. What is another integral calculus is? Now, if someone is watching minutely, we started with 1, 1, 2, 3, 4. This is x-axis. X equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to n. Okay. Now consider there is another curve and equation is g, and its formula is algebraic formula is gx. This is the original curve fx equal to x, for which I have to find the summation, where it is sampled at x equal to 1, 2, 3, 4. I have another formula called gx. This is fx, then this is gx, this is gx. Now gx, what I am trying to do, I am trying to achieve summation x equal to 1 to n fx through equal to gx dx from lower limit to higher limit. This is what I am trying to do. Whatever we want sigma sign summation x equal to 1 to n fx. This is what we want. Whatever we have talked in this session and what we are talking, it is not available in any of the book. Okay, summation x equal to 1 to n fx. This is what we want. Now we want it through integral calculus. Then I'll write it equal to integral calculus means there has to be a function called fx, gx, whatsoever. I have another function called gx dx. This is the basic sign of integral calculus. Actually, we are multiplying gx with x, gx dx, limit from lower limit to higher limit. What I am trying to do is, there is another function called gx, something like this or something like this. And this is a continuous function. This is not a discrete function. Okay, this is gx. And if I talk about gx, then at x equal to 1, there is a height that I don't know. Gx at all, I don't know what is gx. At x equal to 1, there is a height. At x equal to 2, there is a height. I have another function called fx, that is the original function, where it is sampled at different points. There are heights only. But if I talk about gx, then it is not a sampled one. It is a continuous area. If I say gx dx from x equal to 1 to n, it will give the underneath area. This area should be exactly same as summation of all the vertical in fx. Sigma x equal to 1 to n fx should be equal to limit. Sigma is going to limit x equal to lower limit to higher limit gx dx. If I am able to find such a gx function, then I can go directly integrating with dx, lower limit, higher limit, and I would get the summation. Makes sense? I would get the summation. So easy, right? Okay, but how to find gx? But this is the formula. Summation x equal to 1 to n fx equal to limit x equal to minimum to maximum gx dx. Let's take any arbitrary point x. This is origin, this is x equal to 1. Take any arbitrary point x. If this is the x, then consider this is fx. This is fx. This is fx. And this is gx. At any arbitrary x, what is fx? This is fx. Height is fx. Okay. This height is function over x at point x. This is the height. We are trying to calculate. We are trying to add all the fx sampled at x equal to 1, 2, 3. Let's say sampling at any x equal to x. Then we have a height this. What about x equal to x? What is the height if there is a continuous function called gx? That height is gx. If I say fx, then this is the height at x. What will be next sampling in fx? That will be after 1. X plus 1. X plus 1, there will be another height. Whereas gx is completely continuous. There is no sampling like that. So if I say at x equal to x, if this is fx, this height should be exactly same as if I take x to x plus 1, this width, and if I go up and meet here, this is called sub-area. Sub-area between x to x plus 1. Like that, if I add all the sub-area, it becomes gx dx. If I add all the heights, then it becomes sigma x equal to 1 to n fx. This is what we want. This means that if I take any particular height, this height should be exactly same as from this to next sampling this sub area. Then at this sampling, then there is another height at x equal to x plus 1. This x plus 1 height should be exactly same as x plus 1 to x plus 2, this sub area. Sub area of gx should be exactly same as all the vertical height that meet the sub area. Make sense? Okay, means if I take a height of fx at x equal to 1, height of fx at x equal to x, then it should be exactly same as gx dx from x to x plus 1. Make sense? Okay, means fx at x is fx equal to sig summation limit x to x plus 1 gx dx. Okay, now we will solve it. Fx equal to limit x to x plus 1 gx dx. This proof, let's do the differentiation on both sides. Dfx by dx equal to gx. Now fx equal to x, that we know. So dx by dx is 1, gx is 1. We'll try with gx as 1. 1 dx, integration will be x to x plus 1. Finally, it will come as 1. Here it is x, it is 1. Okay, if I divide x by 1, it will come as x, means I have to multiply by x. This is called successive approximation. We'll try again. Now we have set it as x dx from x to x plus 1. It will come as x squared by 2. Okay, if I set x to x plus 1, then it will come as x square will go away. 1 plus 2x plus 1 by 2, x plus 1 by 2 means I got the x. Luckily. I got the x. So now x plus 1 by 2, there it is x. Okay, I got the x. Okay, let's try again. Now instead of 1, anyway, we tried with the x. And if I try with x, it comes at x plus 1 by 2. 1 by 2 is extra we are getting. Let's subtract with 1 by 2 so that we'll get, idea is it should give only x, not anything else. We'll try with x minus 1 by 2. It will come at x square by 2 minus 1 by 2x. X square by 2 will come at x plus 1 by 2. X plus 1 by 2. Make sense? Minus 1 by 2x. X will become x plus 1 minus 1 minus 1 by 2. It will become x only. Exactly perfect. So we have got a gx, that is x minus 1 by 2. Okay, so we have got the solution. 1 plus 2 plus 3 plus 4 plus anything. I can get it through 1 plus 2 plus 3 plus 4. I can get it through a continuous function. People can consider there is no rule for continuous, changing discrete function to continuous function in any of the research paper also. It is not there. I was trying to search it. Okay, because I needed it. How to convert a discrete function to a continuous function. I was trying a lot. Okay, now this is the way. Gx is now x minus 1 by 2. Let's try now. Now, what is the summation now? Let's watch it minutely, what I am doing now. Okay, I have started with the x equal to 1 to like this. And then we are calculating x equal to 1. Consider it. Now I have taken at any x equal to x, and then vertical I took for fx. Then vertical I took for gx x to x plus 1. Let's go little more minutely now what we are doing, because now I have found the solution. Gx is x minus 1 by 2, but at the end, if I'm trying to calculate summation x equal to 1 to n fx, then I have to do gx dx and lower limit to higher limit. Then it will be exactly same. What is lower limit to higher limit that I need to find now? From x to x plus 1, doing that I found gx. That is x minus, this is $1 trillion explanation. Okay, someone can change mathematics at all looking at a successive approximation. We will see many mountains and ditches also. afterwards. Like 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, that will be difficult. Or 1 plus 1 by 1 plus 1 by 2 whole square plus 1 by 3 whole square. Those things will be cumbersome. Anyway, now we will start again. Now this is x equal to 0. We are starting at x equal to 1, 2, 3, 4, 5. Consider 5 is the end or 4 is the end. X equal to 1, 2, 3, 4. 4 is the end. When we are taking any x, then x can be 4 also. Makes sense? At any x, what is fx? And at any x, what is gx? gx gx dx limit x to x plus 1. So end x, when we are talking about any x, then x can be 1, 2, 3, 4. If I take 1, then limit we had set 1 to 2, because we had set the limit x to x plus 1. So 1 to 2, if I have taken x as 2, then 2 to 3. If I had taken x as 3, then 3 to 4. If I had taken x as 4, then we set limit 4 to 5. 4 to 5 it should work. Means more or less we are going up till 5, whereas our sum is up to 4 only. If I saying sum, then n is 4. But we are doing calculation n plus 1 up to 5. Make sense? Okay, means when I am taking final limit, when we are taking final limit, the limit will go from 1 to x plus 1, n plus 1. Makes sense? Limit will go n plus 1. If n is 4, that is the maximum. But in the limit, it will go 1. We have started with the 1, and calculation will go up to n plus 1. Because last one, n to n plus 1, is also coming in our calculation of gx. If I talk about sub area, first sub area between 1 and 2, second sub area between 2 and 3, third sub area between 3 and 4, there has to be 4 sub area. If there are 4 vertical at x equal to 1, 2, 3, 4 verticals are there, making 4 vertical, there has to be 4 sub area, so that dx will work. First sub area, second, third, fourth sub area is between 4 and 5. That also we have to must take. 4 sub area we have to take. Means if I am trying to calculate, the last integration for the actual algebra, it will come as x equal to 1 to n plus 1. That is the fourth sub area. Now we have to do x equal to 1 to n plus 1, where n is the last one. 1 plus 2 plus 3 plus n, where n, if I take the n last one, then n to n plus 1 is the last sub area that we have to take care while doing the integration. So x equal to 1 to n plus 1, and then we have x minus 1 by 2 dx, that will come as x square by 2 minus 1 by 2x. Makes sense? Okay, that will come as x by 2 in bracket x minus 1. That is the solution. X by 2 in bracket x minus 1. Let's put the limit now. Now x, first limit is x equal to n plus 1. It will become n plus 1 by 2, and in bracket n plus 1 minus 1, n into n plus 1 by 2. Let's set 1 here. If I set 1, it will become 0. X minus 1, 1, 0. Means the net calculation is n into n plus 1 by 2. This is what is through algebra also. This is exactly perfect solution through successive approximation. Can someone believe on this? Can someone? No, I don't trust you. What is the word? You said I take any x equal to x, and then I have two functions. At any x equal to x, there are two functions. There are two functions. One function is fx, that is x equal to x. Another function is gx, the way you are saying. Yeah, I'm saying gx. Now you take any x equal to x. At x equal to x, fx is fx, that height must be matched by a sub area. This sub area can be left side also. If this is x, you took x to x plus 1. Let's take x to x minus 1 or x minus 1 to x. Left side also it should match. Why it will match only right side? When I am taking a vertical at x equal to x, that is fx, then I can go for left side also. limit should be x minus 1 to x dx equal to fx. Can you prove that your solution is same? N plus n into n plus 1 by 2. Can you show? Okay, we'll try now. What is there in trying now? Okay, let's try back. Now we have now fx equal to limit x minus 1 to x dx. I have to find gx now. Fx equal to x, and here it is, let's start with the gx equal to dfxy by dx, that is 1. Okay, now we will try 1 dx x minus 1 to x minus x plus 1, that will come as 1, where it is x here. If I divide, it become x. So we'll start with the x dx, x square by 2. Limit is x minus 1 to x square by 2 minus x square. How 1 by 2, let's take outside, x square. That will be x square minus x minus 1 whole square. X square will go away, and it will come as 2x minus 1. 2x minus 1 by 2. 2x minus 1. Up. X minus 1 whole square will become x square. X square minus 2x plus 1. Okay. Now outside minus is there. It will become 2x minus 1. Correct. Outside 1 by 2 is waiting. So it will become 2x. It will become x minus 1 by 2. Same thing is coming. X minus 1 by 2. We'll try again. X minus 1 by 2 dx. That will become that. Okay, x minus. So x we. Oh, I'm sorry. It is coming at x minus 1 by 2, where it should be x only. What is extra here? Minus 1 by 2 is extra here. So to remove minus 1 by 2, I will add it by 1 by 2. So earlier we had taken, first we took 1, then x. Now we'll take x plus 1 by 2, then minus 1 by 2 will go away. We'll try again. X plus 1 by 2. Integration is x square by 2 plus 1 by 2x. 1 by 2 I can, x square by 2, x square by 2 plus 1 by 2x. 1 by 2 I can keep outside. X square plus x. For x square, if I take limit x minus 1 to x, it will become 2x minus 1, the way we had seen last time. 2x minus 1. 2x minus 1 plus we have x. X, if I set limit x minus 1 to x, it will become x minus, it will become 1. It will become 1. It is tedious though. So it will be 2x minus 1 plus 1. Up. 1 gone. 2x by 2x. Alright. We have got a gx, and gx is x plus 1 by 2. Now we will have same equation. Summation x equal to 1 to n fx should be same as gx dx, lower limit to higher limit. What is lower limit and what is higher limit? If people are watching very meticulously, then this is x axis, this is x equal to 1, x equal to 2, x equal to 3. I took any x and went left side this time. If I go left time, consider it is 1, 2, 3, 4. If I go left side, then 4 to 3, one region, 3 to 2, another sub-region, 2 to 1, another sub-region, but I need to have 4 sub-region. Then 1 to 0 is another sub-region. Make sense? 4 sub-region of the gx I am trying to do. That's why it is minus x minus 1 to x this time. So 4 to 3, one sub-region, 3 to 2, one sub-region, 2 to 1, one sub-region, and 1 to 0, another last sub-region. Means integration will go from 0 to n. Make sense? Now here it will go 0 to n. Gx dx. Gx is x plus 1 by 2. X square by 2 plus 1 by 2x. X by 2 outside, it will become x plus 1. That will become n by 2, n plus 1. This is what the actual solution is. Anyone can search in the book. Now people can try x square. X square means, okay, I'm sorry. Now people can try 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5 plus 4 plus 4.5 plus 5 plus 5.5 plus 6 plus n. n means total 2n items. Plus up to n. Up to n means any non fractional number. Up to 20, up to 30, up to 50. Anyone can try. Someone can take this as an assignment now, or 1 plus 1.25 plus 1.5 plus 1.75 plus 2. I can divide between 1 and 2 in 4 parts now. 1 plus 1.25 plus 1.5 plus 1.75 plus 2. Okay, keep it going on. Keep it going on. And then tell me what will be up to 50. Or 1 plus 2 plus 3 plus 4 I am doing up to n item. What about summation from 5 to n? Summation from 5 to 10. Tell me what is the summation from 5 to 10? But if I say n into n plus 1 by 2, then n will start from 1 only, not from the 5. No solution. In algebra, it is impossible to find. Someone has to start from again. But here, what we have, limit 5 to 10, right? The limit will go 1 back, 4 to 10. Makes sense? If it was from 1, then we started with 0. 0 to n, it will go from 4. 4 to 10. X plus 1 by 2 dx. Or if I were taking the last one right side, then it will go 5 to 11. X minus 1 by 2 dx. Here it is x plus 1 by 2 dx. These are $1 trillion explanation. This will change the world if someone proceed in this direction. Okay, like Taylor series changed the world. Okay, now someone would go now. Okay, we have x plus 1 by 2 dx, x square plus x square by 2 plus 1 by 2 x. Makes sense? It is now x by 2 in bracket x plus 1. If I go with the 10, if I go with the 10, if I go with the 10, then how much it will be? 10 by 2 in bracket 10 plus 1. It is 11 into 10 by 2. Makes sense? Minus will go with the 4 now. We'll go with the 4 now. It will be 4 into 5 by 2. Okay, someone will say, boss, you could have used IQ. N plus n into n plus 1 by 2 is the net summation from 1. First try with from 1 to 4 and then try from 1 to 10 and subtract it. This is what you want. This is what we are doing here also. But if I know integral formula, then many complex things also we can do. Okay, this is what I'm trying to say. Anyway, someone is free to try 1 plus 1.1 plus 1.2 plus 1.3 plus 1.4 plus 1.9 plus 2 plus 2.1 plus 2.2 plus like that up to 15. Can someone try? Okay, okay. Someone say I will do. I can do on. Now there is no formula. N into n plus 1 by 2. That will not work at all. Okay, this is called sum series to integral calculus. Amazing, mind blowing, purely new invention that has never been seen in any mathematical book. Anyone can try now. Okay, so this can be a very good assignment that people would try it. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. We are thinking of writing a calculus book. People who are supporting nicely, then we would mention in the kind of acknowledgement or whatsoever their names.